If you are looking to fine tune Mistral family of models, then now you don't have to use third party tools such as from Hugging Face or anywhere else to fine tune that. Now you can use this Mistral fine tuning library from Mistral itself to do that task. One thing straight up I need to tell you that you cannot fine tune Mistral models by using this library on commodity hardware. You would need at least A100 or H100 GPU card. Once you have it, it is simply a breeze, and I will also show you the steps in this video. Before that, let me give you a bit more quick overview of this. So Mistral-Finetune is a lightweight codebase that enables memory efficient and performant fine tuning of Mistral's models. When we say fine tuning a model, what it means is that we have a base or pre-trained model, and then we take our own custom data set, and then we adjust the weights of the model so that model will be aware of our own custom data set. There is a technique called as LoRa or low rank adaptation, which is a training paradigm where most of the actual weights are frozen and only 1 to 2% additional weights in the form of low rank metrics are trained, which saves memory, which saves cost, and a lot of other benefits. There is a slight loss of performance, of course. So if you're looking to use this Mistral fine tune, then make sure that you have good A100 or H100 GPU. Also, this code is optimized for multi-GPU single node training setups. But if you have a smaller model such as 7 billion one, then a single GPU is good enough. Okay, now let me show you that one prerequisite which you need to make sure you have, and which is the preparation of custom data set. And remember this, whenever you are fine tuning a model on a data set, the biggest thing which can make a difference is your data set. If you format your data set as per the requirement of the model, then your fine tuning will be of superb quality. But if your data set is not good enough, whether your data quality is low or your format is not correct, then no matter how much you fine tune, the quality of the resultant model will not be good enough. There are two types of data files which this Mistral fine tune can handle. First is pre-train, as you can see on your screen. This is simple text key value pair, like text and what exactly the text is. You can just simply throw in and it is going to work on that. Or you can use this instruct format, where primarily it's a conversational data between user and whatever content you are giving, and assistant, and this one. By the way, when the model is doing the fine tuning, only it calculates the loss on this one, because primarily the model has to respond to the query. So if the model doesn't respond correctly, that is a loss, and that is what it tries to fine tune. That it tries to fine tune the response of the model as good as according to your data set. So this is what you need to format your data set in. If you want to do conversational, if you have a simple text oriented data, just make sure that it is in this format. Now another thing is that if you want to do function calling with Mistral and you want to fine tune on that, then make sure your data set is in this format, where we are telling it that system message, user message, and then this is a tool call or function call, where we are giving it the function name, what are the arguments required, and then what role it is playing. You see that there are a lot of tools here, a lot of examples. All you need to do is to substitute your data accordingly, and you can use any Python library in order to accomplish that. So they have given all of this information on their GitHub repo page, and I will drop the link in video's description. Now let me show you how you can do the actual fine tuning with this one. So this is the Colab which they have provided. All you need to do is to substitute it with your Mistral model and with your own custom data set, and you are good to go. But of course, as you can see, it is saying that you cannot run it on free Google Colab. Unfortunately, you would need a Google Colab Pro account with A100 and 40 GB of RAM at least. So first up, they are simply installing git cloning that GitHub repo which I just showed you. Then they are installing all the requirements there. Once that's done, they are downloading the model. You can also download it from Hugging Face if you like. Then they are unzipping or untarring that file. This is done with the tokenizer, and then they are showing, okay, these are the tensors of the models, and then they are preparing the data set which I just showed you. So there you go. So we are going into the content, create a directory, data, then go to that directory and then import pandas and read this data set. There you go. So it's a Parquet format. Once that's done, just split it into training and evaluation, and then make sure that it is saved as a JSON-L files, which I just showed you in the first one where we were preparing the data set. Once that's done, you can simply check out the content to see if it is a good enough, and then go to the Mistral-Finetune directory in the GitHub repo, and then from there we are simply checking the training data format, and then we are just checking the data that everything looks good. And from here you can also run that validate data. This is what I really like about it, that they have also provided a validation script that before you run the training you can validate it. So, and then they just are running it. I'm just scrolling down to make sure. And once that's done, just set your environment with the CUDA devices. We have only one device, which is 0. And then let's define the training configuration, which is the same stuff where we are defining the context length, batch size, what is optimizer seed, what is the checkpoint frequency, and CKPT, LoRa. If you don't know what these parameters are, I have already done a few videos where I go into the way more detail. And then once that's done, they're just saving this file, the config file, locally. And then from there, this is the whole command which they are running, the torch run, to start the training. And of course that takes a bit of a time, of course. And then you see that this collab which was run by them has already all the information where parameters are being processed, and then fine tuning has started, and it goes on and on. If you just look through it, the loss is coming down, as you can see here in this column, and then it just goes on and on. I'm just trying to see if there is any time they have put in, how much time did it took. So ETA is around, I think maybe it is 19 hours. I'm not sure. This is just the time, it's not the 19 hour. I think it will finish it by then. Anyway, so I think this is the one, maybe, I don't know. So if you want to do the inference, they also provide this Mistral inference library, which is quite good, by the way. And then from there, all we are doing we are just doing the inference with the model which you have just fine-tuned. And this is a simple completion request with the tokenizer and the model, and this is your response. So all in all, a really good library. I wish I had the A100 GPU, I would have shown you, but still good enough. If I get my hands on any A100 GPU, I will also walk you through as how to do it. But that's it, guys. Let me know, what do you think? If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.